are your nerdy aunties, Tika and Veronica, and this is What on Earth podcast. In today's episode, Tika prepared something special.
Yeah. Do you know about fossils, Veronica?
I remember vividly right now in my head this episode of Phineas and Ferb, and then there is this episode when the father, I think, goes to the museum, and then there's this audio recording you usually get in the museums, when you put the headphones, and then there's this fossils, ding ding ding. And this is all I remember, but I do know basic.
Yeah. So we're going to talk about fossils today. And before we start digging in, not literally, we're not going to dig in and actually find some fossils. I think it would be nice to have some kind of a definition or description of what are fossils, because I think most people think only of dinosaur bones when they think of fossils and the big shiny stuff, but there's a lot more to it. So I'll first give you a very dry definition. A fossil is basically anything that resembles organisms that you can find in rocks. So anything that has been an organism in the past, or anything that can be linked to anything living in the past. And we divide them in two types, basically. So we have the bodily fossils, so the ones I mentioned just now, right? The dinosaur bones, for example, the shells, anything that is made of a body part of an animal. The same for plants, by the way. We also have plant fossils, obviously. And we have the trace fossils, which are things like footprints or animal excrements, such as coprolites, we call them. It's, yes, ancient poo. And then we have the ichnofossils, which are the traces of fossils. So the footprints, but then more like the digging or the burial holes you can still find in the ground of whatever animal that dug or walked around at that time, which makes it a bit more broad than you might think at first, right?
Yeah, definitely. When I think about fossils, the first thing which pops in my head is those, shells, the ammonite fossils.
Yeah, those are pretty.
Which are quite pretty and quite common, I would say. Every geology student during the first years of bachelor goes to one of the mines near Krakow in Poland, and you just hoard them away.
Yeah, you cannot not see them at the south of England, for example. The whole Jurassic coast, the Dorset coast, is filled with these things. And why that is, we'll talk about a little bit later, because there are certain conditions that make them easier to survive all this time and erosion. But I think for that, we first need to see how do fossils form, because not everything gets saved in the fossil record. We have, for example, the fast burial, which makes fossils more easily preserved, because if you have bones, for example, lying around, lots of other animals will take them. We see that now, like hyenas. There are these animals that take the bones anywhere, and you just don't find them anymore. So we need.
So, for example, you're talking about animals which live on the ground or in water, because, for example, I think most fossils are found. It's water. Living creatures, right? Or where water loving creatures. So can we also preserve animals on the ground?
Yeah, it's possible. It's harder though. And that's because on Earth there are a lot more, compromising circumstances, I would say, for fossils to, not survive the conditions. And one of them is fast burial, so fossils stay hidden more easily in the water, because you have more sedimentation happening there. On Earth we have more erosion, so the fossils would erode away instead of.
And what is
Yeah, what is erosion? That's a good question. So you have these rock formations, and they get broken down by either water or wind into very tiny particles and then transported to the sea. So generally the high parts of the earth erode faster and more, and then everything gets flattened out over time.
It's like slow destruction of the rock.
Yeah. That sounds very horrible, but yes.
Slow destruction of the earth.
Yeah, and the same happens with fossils, generally more above water, because the erosion is higher above water, generally speaking. It's very broad. There are always situations such as storms, for example, that mix everything up, or volcanic eruptions, anything crazy. But that's not what we're talking about here. It's the slow erosion that makes preservation on Earth harder than in the ocean. And I mentioned some of these fast burial happenings already, right? Such as a storm or avalanche, for example. It all helps with the fast burial of fossils for them to be easier preserved. Then we also have the situation where there's no oxygen, so there's no degradation because of oxygen. Oxygen is a yeah. How do you explain it? It's like it kind of acts like an acid, I would say. How do we say oxidation?
Yeah, it
Oxidation.
oxidizes.
Yeah. So it breaks down organic components, which makes organic material harder to preserve in oxygen-rich environments. And to compare, an oxygen-rich environment is just basically anywhere on Earth, above ground, nothing special happening. But in the water, for example, especially deep down in the water, there are situations where you have very little oxygen because it's all used up already in decomposing organic material, and therefore it's more easily preserved because it's not broken down by oxygen, logically.
And it's not eaten by other animals then, for example?
Yeah, that is a possibility always. But generally, if there's low oxygen, there's nothing much alive in the vicinity. So the body of whatever fossil is going to be created is just put down and then preserved on the spot. And you see this a lot with, for example, the crinoids. So in the past they are extinct now, but it's like the sea lilies, I think we call them in normal English,
Yeah, yeah.
not in Latin English.
They look
Um,
like lilies.
yeah, and I think you can compare them to corals. They were weaving around with these flower-like structures, filtering algae from the water. And when they die, they just drop down right where they lived and then either decompose or get moved by a storm, or if we're lucky and it's calm, they get buried and then you can find them again. So they live in like shallow oceans where there's what you call it, non-energetic environments basically, so they can just float around
So
and
there are no
be chill.
waves which would spread around the
Yeah,
bones.
yeah. So you can usually find them in the fossil record all still in one piece, which is pretty fun. So they also die, and then in low oxygen environments they get preserved better. Next is a form of mineralization, which is a bit harder to explain, but I think you can compare it to well, we have some examples. For example, the pyritization of different shell-like creatures. So the ammonites you already mentioned, they usually in very iron-rich environments, the iron clings to the shell, and I think under pressure it gets transformed to pyrite. Is it pressure? Do you know?
I think maybe that would be another process like a chemical exchange, and then it would replace the structure of the fossil, some sort of. I think they're also changed in opal, right? Because I saw some ammonites being like opalized, very nice, very rainbow.
Yeah, it's very pretty.
Very pretty, like.
They're very cool.
So this is the same process. This is like, I guess, the silica gel just replacing the calcium of the shell and filling the cavities where the bones or the shell was. So I guess would be similar. With pyrite, I'm not a specialist on pyrite, but I would probably by proxy say that maybe it's just chemical process which just replenishes instead of like crystallizes pyrite where it was calcium.
Yeah.
We can
and
check
this is
it
also
out.
very specific for the environment, right? The iron has to be present, the
Sulfur.
fossils has to be there. Sulfur, it has to stay there, like no other animals eat it. So this is a bit more rare to find, I would say. Especially also because most shells dissolve after some time because calcium is not always as present in the water in the oceans. So below a certain depth, for example, calcium is just not as present, so the shells dissolve. This is also why these animals never live at the bottom of the ocean, because their shells, their homes, will literally
slowly
dissolve.
Die.
Very dramatic. Can you imagine just your home dissolving because you moved too far or something? Yeah, it's a fate you don't wish upon anyone.
No.
Yeah, so yeah, that also makes it hard for some fossils to stay the way they are, and so we can actually find them some time later. And then we have the last way a fossil forms, which is by, for example, freezing. So we see a lot of ice age animals and stuff frozen into permafrost, and then we find them again. I would say they're not fossils in the traditional sense because I mean, they're just frozen animals basically, but it still contains a lot of vital information from these animals because you preserve fur, for example, which is something that doesn't always preserve. It's easily decomposed because it's not a very hard substance like bones. So this is an interesting extra type of fossil or whatever you want to call it. I would say it's a fossil.
If we consider amber, and then you have like preservation of those, mosquitoes and little things, is it also considered like fossil, or how would you call it?
Yeah, amber was my next point that I would also put in this category because it preserves the full anything of whatever it is that gets trapped in there. So, for example, the mosquitoes, there are examples that they found this mosquito with still blood in its stomach.
This is
So
how
you could,
Jurassic Park started.
yeah, yeah, this is all very. I mean, let's be clear, this DNA is already very broken down. You cannot do anything with this, only fragments, basically. And it's so old if it's in amber, especially these mosquitoes. They were like a million years old, I would say. But yeah, it's a cool thought experiment, I guess, to see if you can still
Reconstruct.
find your way into the past or something.
Yeah, I there was this recent, I mean it was not recently, but it was a couple of years ago we had this popular science news coming around like with the lizard preserved in amber, but then there was the question whether it was true or fake. I had no idea how it settled, but do you remember? I think there was like a half lizard somewhere in the amber. I might, right now
Yeah,
hallucinating.
there are many of these examples. Also, the mammoth DNA they want to put into elephants and try to breed some crossbreed thingy. I
Yeah,
don't believe in it.
I think it's
I
like
think it's
popular science fake news,
yeah.
whatever you call
I
it.
think I think the DNA is way too fragmented and broken to do anything with it except get some information from the remnants. But it is a great way to get more funding. If you have a good story, it's a great way to get funding for your research and be able to continue. So
Yeah,
they're
how is
playing it smart, I guess.
that's like quite interesting topic because paleontology is such a broad discipline, right? It's not only fossils and dinosaurs, but it's also like those microfossils and all the records of
Yeah,
climate
climate.
reconstruction. So when we think about paleontology, like when I think about paleontology, I think Jurassic Park slash Indiana Jones, but it's probably much more needed instead of like, people going around and collecting stuff. It's also contributing to climate reconstruction, right?
Yeah, yeah. The paleo world is very varied in that way. You have very many disciplines with specific topics. So paleo basically means old or in the past. Anything in the past is interesting. And fossils are just a tiny way of reconstructing that past and using it to predict the future or to know more about us as humans or other species. See how everything is related. Yeah, so it's only a tiny part, which is interesting.
Do you have like a timeline? Like, what was the oldest fossil ever found, and what is the freshest piece of meat found?
I think the oldest fossil they found were these combinations between some kind of moss type lichen thing. So this symbiosis between fossil plants and bacteria. But the science is a bit conflicted on that because it's so old, it's so hard to reconstruct. The oldest, yeah, the oldest fossil, I'm not sure about the dates exactly, but I think from the earliest plates. So that would be 3.5 billion years ago.
That's pretty old. Yeah.
But the most interesting fossils start to happen from the Precambrian era, so that's like 600, 6.5 million years ago.
Is it Ediacara? Is that one, or is it?
Yeah,
Yeah.
yeah, yeah. That's the Precambrian, I think, and then you get the Cambrian explosion with all these squishy animals that are. We will talk about all
We'll
these
probably talk about Precambrian
jumps later.
explosion in the next episode because this is pretty interesting.
It is crazy how fast everything has evolved over time because the Earth is like 4.6 billion years ago, and only 500 million years ago, we really started getting complex creatures, or what I define as complex creatures, so sponges and things that are squishy and bigger than a few cells, I would say.
We get record of bacteria. Like, can you get bacteria fossils, or is it too small and too fragile of an organism to be preserved?
There are bacteria that are very big. So you have these plant-like bacteria, the very early forms where bacteria started to work together, and there is this photosynthetic bacteria that go work inside others, and they get giant, ginormous cells, like multiple centimeters big. So you find these in the fossil record, but very rarely because they are so squishy. They're very hard to preserve.
So, like the favorable conditions to perfect recipe to make a fossil, it would be you have to have a hard shell or bones or hard parts of yourself, and then preferably you should die in low oxygen environment during the violent event like tsunami or avalanche, and then it's supposed to be cold, and then maybe not weather, so there you don't have any, there's no weathering happening. So that's more or less the perfect idea scenario.
Yeah, very specific. And then if that happens in the ocean, we also need the rocks to go up and be visible at Earth because below the surface you don't really find them
we
either
cannot find
as a
them.
human. Yeah, we cannot.
So this is generally like very specific type of events, right? So we are very limited in our understanding of the past because we only have access to those records which happened in really specific events, right? You don't have, let's say, avalanches, landslides, mudslides, ash falling down to the ground. You don't have these events every day.
No, exactly. The fossil record is heavily biased to, well, it's very weird to say survivor's bias, but I guess it kind of is because you have to have very specific conditions for the fossils to be preserved and actually be found as well.
What about human fossils, like early human, right? Humanoids. These are also considered fossils, or these are already considered like archaeological findings?
Oh, that depends. Okay, so I have to add in some background. I did both my bachelor and master thesis on human evolution, so it depends on when you would find them. Like, for example, the Homo sapiens sapiens as we are known today, we are only 50,000 years old. So, in my opinion, I would say everything after this mark is archaeology. Also because it's not consolidated inside actual layers of rock. And before this, you have some way of, well, actually preserving it in a rock. And then I would call it a fossil. But this definition is very different for every researcher and also depends on what you can actually still find of these times.
Yeah, I mean, I think I mentioned that in our previous episode that geology is just not very good with boundaries. They're like, geologists are like, this toxic partners who just don't know your boundaries because like it's nature is never linear, right? We cannot put okay, let's say everything 5,000 years ago is paleontology, but everything younger is archaeology because the boundary is quite blurred, right? By the conditions, by the state we find it.
Yeah, definitely. And also the time we live in, because everything is changing so fast and it depends on how fast does everything consolidate into rock, so you can actually call it stratigraphy or either fossil. Maybe we live in like this boundary period where we in 2 million years would put this line of before it was this and now it's that. It's also important to be able to date it very specifically, like a few thousand years off. For us, that's nothing. That's super precise. Yeah, for you and me in daily life, 1,000 years is quite a lot.
Quite a lot, yeah.
Yeah.
We will be talking about geological time in the next episode because this is something which we have to make very clear. Like why we operate, million years, billion years, what is the scale, why the scale is so big, and also what are implications for geology.
Yeah. I think it all depends on the precision as well in how you can measure it, right?
Yeah.
We can simply not measure smaller.
Yeah, I think we should do a whole episode about dating, like, you dating fossils and organic matter and me dating rocks. Because you can date rocks using minerals, using specific tracers, and also using isotopes, which I think would be interesting for people to know.
Yeah, which is a very nice bridge to the next thing I want to talk about, and that is how or why could we use fossils? Why are they so cool? What do we use them for? And one of them is the age correlation of different units of rock. So very nice. Because certain fossils are very specific for one type of rock and one type of time. And I mentioned stratigraphy, right? So you have the different layers of rock, and stratigraphy is basically the science of these rock layers. And it concerns itself with the composition of the rock, the order in which they are deposited, and the age of these layers. So it's only sedimentary rocks usually. I mean, it involves a little bit of other.
We could kind of correlate, for example, layers of ash. So to correlate the big volcanic eruptions, which were like globally spread. Or I think they also use layers of isotopes to correlate for major like asteroid impacts, which we can talk later on. But let's say 95% of the job probably is done through sedimentary record.
Yeah. Yeah, and that's what I mean right now by stratigraphy, in which you find fossils, because these are layers that are deposited over time. And that is the definition, I guess, of sedimentary rocks. So we try to understand how they are deposited and how old they are and how they relate to each other, because sometimes you have a period of deposition, period of erosion, then deposition. So you have like an age gap or time gap in your record.
Which is called hiatus professionally.
Yeah, very good.
I remember stuff.
Yeah. So that's one way to use fossils too. For example, if you have rocks at one side of the world and the same rock at the other side with the same fossil, you know these rocks are basically the same age if this fossil does not happen anywhere above or beyond in the layers. So it's basically like a one big puzzle of understanding all different layers in the position on Earth, in which fossils can help a lot.
It probably also doesn't go not necessarily only layer by layer, but also it can help to correlate and recreate paleocontinents, right? Because like if you have some group of fossils in region here for let's say Africa, and then you find the same record of fossil in South America, then you can more or less recreate the drift of continent over time. Is it correct?
Yeah, I think this is actually the case for Africa versus South America, because they fit so well together, and I think we found some fossils as well on both sides of the now ocean. Yeah.
So it's also
so definitely
also like reconstructs the map of the Earth through time.
Yeah, it definitely helps. Yeah. And another thing I find very cool about fossils is how we can see, like, have a small window into the biodiversity of the past, because you see all these crazy, weird, different type animals that once lived and now we cannot see anymore. So there's this, I think it's Cambrian thing, it's called Vivaxia, and it's a thing with a lot of spikes. And for a long time we interpreted actually the other way around. So the legs are up in the air and then it walked on the spikes. And then, like, the science somehow changed, or we figured out some new stuff, or we found new fossils. You tell me. And then we figured out it was actually the other way around. And then, these fossils are so weird sometimes. You don't know what you're looking at, but we get a small glimpse into the biodiversity with these finds.
Didn't they right now have this theory that dinosaurs had feathers and they didn't look necessarily like lizards?
Yeah, and that's actually proven as well, I think, by some amber fossils of feathers, or by some pigmentation in the skin that was somehow preserved. Yeah, and it's also, they were very colorful, which I find very funny.
Very cute.
Like big dinosaurs that were kind of bird-like.
So cute. So, because also that's interesting, like how we scientists are interpreting the skeletons or the remnants, because like since we only see the hard part, we have to extrapolate the soft parts, right? Do you know anything like how is it done? Do they take animals which are right now existing and try to like trace back similarities in the bones or in the structures they see?
Yeah, that's a good question. I'm not sure. But sometimes in fossils you can see the indentation of the outline of the animal still. Even though the skin is not preserved anymore, you still see the imprint in the rock sometimes. So you see where the outline of the fins, for example, were. But these are very well preserved. So, for example, the ones that are buried in oxygen low situations, where this skin imprint is saved by putting a layer of mud on it.
Like you have those slates with fish inside, right? You can have those fossils of ancient fish. When you separate slates, which are rocks, we have very nice separation cleavage, and then you can like separate them, and whoops, there's like fish. And there you can actually not only see the skeleton of the fish, but you can also see the outline of the fins and the whole fish, right?
Yeah, exactly.
Pretty rare.
Yeah, those are the nice fossils, I would say. The ones you don't find often, but are very interesting scientifically. So if you find fossils somewhere and they are very nice, please at least write down the location and orientation or layer you find them in and show them at your local museum, because it's sometimes the missing link you would need for further research reconstruction.
That's actually
purposes.
quite interesting. If anyone by accident finds fossils, what should they do? Who should they call? What to do? Like, you know, like everyone probably wants to have a nice fossils in their collection, but is it worth to have them checked by someone, or what is the procedure here?
Yeah, so often you cannot take them. They're property of the government of the country you find them in. So you have to declare them. I mean, not all of them. Some are not interesting enough to declare. If you find the fifth ammonite, yeah, it doesn't add much to what is already there. But I would say please make a picture of how it was oriented in the rock and which layer, and make a picture also of the size, and then go to a museum. Usually these dig sites have some specialist or some guide around that can help you get them to the proper location for further investigation.
Yeah, because like, you know, I would not know if I found some interesting fossil from non-interesting fossil if that would be ammonite. But I guess if you start finding bones of dinosaur, which are probably just big as bones, then for sure contact authorities. I'm just sometimes worried that if I find something and I just deem it yet another ammonite, and it turns out to be like random unknown species of ammonite, but also like I don't want to right now, because probably all the paleo people in the world will be like, oh god damn it, please don't, because they will start getting emails and photos from those hobbyist people with millions.
Is this?
It's like, did I discover a new species? Can you name it after me?
There should be an app for this. I'm not sure if there is one, but it would be very nice.
Yeah, I mean, we live in the AI era, you know, we should just like make a photo, put it through Google AI and be like, hey, should I concern someone with this, or can I just take it home?
Yeah. I mean, you have this for plants nowadays and also small animals. It's called Obsidentify, and you can just scan or make a picture of this plant, and then with certain amount of accuracy, it usually says I'm so many % sure this is whatever plant it is.
Yeah,
it's pretty cool. So it should be. Yeah, I think we should make that for
watermark. This is our idea. We are gonna develop this app. Please do not develop this app before us.
Yeah. Good luck, because I don't know. I don't even know where to begin, because sometimes it's these very tiny differences or size differences, or it's just a suture on an ammonite that is different, or a leg that is shaped some specific way, or a tooth that has like its curves left or right. Yeah.
Crazy idea, but what if...
It's so specific. Yeah.
What if some of those ammonites that we deemed to be different species are just like ammonite which were underdeveloped? Or, you know, they were just slightly different. And like, you know, humans are different, and there are also humans with like body dysmorphia and stuff like that. So how do we know that we talk about specific different species and not just one singular, you know, weird piece of ammonite which just was born this way and was slightly freaky, but it still belongs to that family?
Yeah, I would say that's also a bias of the fossil record. You never know if you're looking at a juvenile or an adult or a male or female. Sometimes you can infer. And especially with bones, you can see how well developed the bones are. So we usually put them in a scanner, or the synchrotron, for example, the big thing that you are very hyped about. I don't know much about it.
I'm so ashamed that the first time we, in this podcast, the synchrotron term was, and it did not came out of my mouth.
I'm sorry. But Yeah, they can scan. I think it's scanning. I'm not even sure how it works. I'm
It
sorry.
does everything. It's like
It does.
Thermomix for science.
You can make 3D models of your fossils with this thing, and it's pretty cool. You can actually slice them up real nice and then look at the bones. And we usually compare mammals with mammals that live today. And then you can see how the density developed, and that usually differs between juveniles and adults. So that's a way where you can see those age differences. But I think a lot of it is misinterpreted as a separate species just because of size or just because of juvenile
Female
things.
versus male.
Yeah,
Also,
yeah.
maybe just one being just freaky species and it actually belongs to this, but it had some disease and it just deforms its shell or whatever.
Yeah, but just think about some animals that live today, like frogs, tadpoles. You would say it's a different species because it looks so different.
Yeah,
We
totally.
don't have many characteristics to measure with in the fossil record.
Yeah, if I
So
would see a baby frog, I would be like, okay, you're a fish.
yeah, yeah, right. You would call it a very different species, and it's the same with these trace fossils. How do you know that this animal has made this trace and not that other one because it was walking on different legs? Who knows how many legs this thing is? Yeah, it's very hard to say, and I think a lot is misinterpreted just because we don't know enough.
Can you talk a bit about the trace fossils? So, like the fossils which are made by activity of the animals and not being the animals itself?
Yeah, yeah, of course. Those are the ichnofossils. So for dinosaurs, it's pretty obvious that these huge paw prints are made by something very big, and the only thing we see is dinosaurs. But we also find these traces of trilobites, for example. They are the underwater crawly creatures that you
Cockroaches
see a
of
lot
the ocean.
represented. What did you say?
Cockroaches of the ocean.
I guess that's what you call them. We have this crab kind of thing that looks like it's still alive nowadays, and they leave very specific, well, crawling traces on the ocean. And we only know this because at some point we found this trace fossil with a trilobite at the end, dead. So it has, so you have to preserve both the trace and the animal, which is even rarer than just the animal because these trilobites have hard shells, so they're easier to find. And I think it's the same with, for example, these, yeah, I want to say mollusks, but no, yeah, it's a bit of a vague term for non-paleo people, but those are the shell type creatures, the soft-bodied, yeah, yeah. Are they snails?
Slags?
Like, yeah, like mussels
Like mussels. Okay.
or like oysters.
Okay, yeah.
Those are mollusks.
I never
And
heard this
they,
term.
yeah, no, well, fair, very fair. But they are like tongue kind of structures, so they dig their way with this huge tongue through the sand, and you can only know these burial traces are from them because you find them actually in it still. So you see this
Pattern.
disturbed sand or compacted sand a bit differently than other parts. But yeah, these are also the environments where they live that are easily eroded because they're usually shallow water creatures, I think. So yeah, it's hard to find sometimes.
And can we talk about my favorite type of fossils, which are the coprolites, of course?
Fossils. Yeah, so actually, when I was studying in Uppsala for my master's, the French group at EBC did a lot of research on this, and they also put these coprolites into the synchrotron to scan. So you had 3D models of ancient poo, basically, and they could see what was eaten. So they found some fish shells, I guess, and some insect legs or material still in the coprolites. But then the hard thing is, who made this ancient pile of poo, right?
That was my next question. Do you
Yeah.
guys know, was it animal, like which type of animal? Was it human? Was it fish? Was it whatever, bear?
Yeah, that's very hard to discover. I think for most of these coprolites, they try to correlate it to fossils they found where they still have the intestines intact. So you can see what's in the stomach there. You compare it to what's coming out, and then, well, you can sometimes trace it back to an animal, sometimes the shape as well, because this big pile of poo cannot be made by a tiny insect. That would be weird and very disturbing.
Very disturbing picture in my head now.
Yeah. So I think it's both size and content, maybe composition as well, but we all know composition can change depending on diet, depending on environment. But they can usually correlate the stomach contents to the coprolites and then to environment as well.
Yeah, that's interesting. So like we know that there's a poo, but now you have to figure out what left the poo. It's like being a hunter 100 million years ago.
I guess it's the same to your example last time, like a murder scene, and linking all different clues to each other and trying to come up with a story that makes sense.
Your
for
clues are
that
just
situation.
happen to be a bit shitty.
Yes, shitty preserved as well. Yeah,
Mine are shiny, yours are shitty.
we cannot all be fancy like you.
Sorry, I'm gonna leave my dad's jokes behind.
No, please.
For now.
Please do not. Yeah. So I guess that was an introduction to fossils. There is so much more specific information to talk about, but at least now you know a little bit about how they're formed, how they are preserved, how biased the fossil record is,
Yeah.
and hopefully where you can find them.
Yeah, and now we know that also it can help us to reconstruct the climate and where the continents were, and that paleo people like to dig in shit.
Yeah. We're the shitty people.
Nah, you're fantastic people. I absolutely, admire paleontologists because they do have a fun job. It's like being Indiana Jones or Jurassic Park.
It's funny though, because within geology or within earth science, it's usually the discipline that is, well,
Mocked.
hated the most or mocked the most.
Yeah, we do a lot of jokes about paleo people. Yeah.
We're
sadly.
just dinosaur people, but that's very niche.
Very niche. Yeah, this is something also like that there's so much variety in paleontology, right? It's the same like when I was talking about geology and rock science, that you have all these sub-disciplines. How does it work in paleontology? Like, do you name it fancily? Like, like we have mineralogy and gemology, and then you have sedimentology, and do you have a lot of orgies in paleontology, or you just put yourself as a paleontologist?
No, there are definitely many people that find themselves special and naming themselves different. So you have paleontology, paleobiology. There's this study about like developmental biology. It's also called, also part of the paleontology section. So yeah, there are many different.
And when you were studying human evolution as a part of paleo group, did you have your own name, or you were just a paleo?
Yeah, I think it's a paleontology, but the human evolution group is a very different group indeed, because they all find, well, okay, disclaimer, this is my opinion, but they all find themselves very important. Want to name a species after themselves, even though it's clearly the same species. So there's a lot of debate in that group. That sometimes is really rough.
We should definitely do episode on scientific drama. I already have ideas.
Science beef is
science
beef. Yeah. It's interesting to see all these papers disputing each other and just yelling at each other basically for being wrong, even though it's maybe not even wrong. No one is very objective in these cases.
I heard that there's a lot of drama in the dinosaur realm. So like I have very weirdly, I have, one of my closest friends like you, and then one of my other closest friends, shout out to Clark, is also a paleo geek. So like I get all my beef from the paleo world. So it would be interesting to just get to know more about it, and maybe listeners also want to know how scientists fight, which...
Well, it's messy. It's not pretty.
No, we publish each other in papers and dispute each other's on paper. So we have all the receipts, guys.
Yeah, or steal each other's research and just publish quicker. Yeah. It's messy.
Yeah, okay. But I think this is enough for now.
Let's leave it at this.
Yes. It was fantastic, Tika. I love listening to you when you nerd out on the stuff you love.
Thank you.
And we're gonna come back to you, as always, with more stuff about Earth, because this is the best planet. This is the best planet on Earth.
And with that, we end the episode. Thank you for listening, guys. Please do not listen again.